Hey, what's going on, guys? So, Mr. Flores here, and today we're going to deal with matrix basic operations. All right. What I mean by that is we're going to do addition, subtraction, and then a thing called scalar multiples. All right. So, basically, what we have here is we have two matrices. We have matrix A, which is 0, 7, 8, 10, 12, negative 2. Matrix B is negative 2, 10, 12, 5, negative 3, negative 6. All right. Now, in order to add or subtract matrices, we must have two matrices that are the same dimensions. So the first one is 2 rows, 3 columns. The second one is 2 rows, 3 columns. Good, I was worried. So right off the bat, we know that we can add or subtract these two matrices. Okay, so really I'm going to say let's do A plus B. Okay, so all you have to do is go to row 1, column 1 in matrix A, and we have 0. We are going to add row 1, column 1 in matrix B. So it's 0 plus negative 2. Row 2, column 1 is 7 plus 10. Okay, then we have 8 plus 12. Then we have 10 plus 5. Then we have 12 plus negative 3. Then we have negative 2 plus negative 6. And that, in a nutshell, is it. Okay. Again, it's nothing too hard or nothing crazy. You just take each corresponding part of the matrix and add them, or whatever operation you're doing. So 0 plus negative 2, yada, yada, yada. 0 plus negative 2 is negative 2. 7 plus 10 is 17. 8 plus 12 is 20. 10 plus 5 is 15. 12 plus negative 3 is 9. Negative 6 plus the negative 6 is negative 8. And our answer is negative 2, 17, 20, 15, 9, negative 8. A quick way you can check to see if you're right is look at the dimensions of your solution matrix. When you add or subtract matrices, the solution matrix must be the same dimensions as the two starting, or the 3 or 4 or 5, however many matrices you add, the dimensions never change. All right, and you may ask yourself, that's obvious, Mr. Flores, but when it comes to other types of operations, it's not always so obvious. All right. So I'm going to do another one quickly. Let's do B minus A. Okay, so again, you take each part of B and subtract that part of A. So negative 2 minus 0. 10 minus 7. 12 minus 8. 5 minus 10. Negative 3 minus 12. Negative 6 minus negative 2. Okay? And now it's just algebra. Alright, so, now it's just adding basic arithmetic. Negative 2 minus 0 is negative 2. 10 minus 7 is 3. 12 minus 8 is 4. 5 minus 10 is negative 5. Negative 3 minus 12. Why did I just rewrite that? That is negative 15. 6 minus negative 2 is really 6. Negative 6 plus 2 gives us negative 4. Again, check to make sure our answer is the same dimensions, and it is because we're smart. So we know that B minus A is negative 2, 3, 4, negative 5, negative 15, negative 4. All right. So again, there's always a time when what you're doing doesn't work. So let's say A is 6, 7, 0, 5. And let's say B is equal to 7, 8, and that's it. If you want to add B and A and B, you can, except your answer is just going to be no solution. And the reason why you technically can't is because they aren't the same dimensions. This is a 2 by 2. This is a 2 by 1. The dimensions are not exactly the same, therefore the answer is no solution. Okay, so that's pretty easy, pretty self-explanatory, how to add and subtract matrices. So now what we're going to do is scalar matrix multiplication. Okay, sounds scary because, well, the word scalar sounds scary. At least it does to me. It reminds me of like dragons and stuff because of scales. But in reality, it's not scary. The word scalar is really just a number. So what this means is, say we have matrix A is equal to 0, 7, 8, 12. Multiplying matrix A by a number would just be saying we're going to multiply 2 times A, which really is just 2, and then matrix A. Okay? All you're going to do is take every value in A, multiply by 2. So you can think of it as you're distributing the 2 to every single part. I mean, mathematically, it's really not distributing the 2, but you can think of it that way. 2 times 0 is 0. 2 times 7 is 14. 2 times 8 is 16. 2 times 12 is 24. All right, and in a nutshell, that is matrix multiplication. Okay. The one thing that I would stress is, say we have 0A. That's 0 times 0, 7, 8, and 12. Okay. 0A is equal to 0 times 0 is 0, 7 times 0 is 0, 8 times 0, 12 times 0. Okay. Write your answer like that. Make it a 0 matrix. Don't just tell me it's equal to the number 0, because you still need your solution to be in a matrix. Nothing's going to change. So that's that. And now I'll just do one that we're going to combine everything we just did. So we'll say A is 7, negative 2, 0, 8. We'll say B is 0, 2, 4, 3. Okay. Now let's combine it. Let's get really funky. So let's do 2A plus 3B. All right. Well, first, let's find out what 2A is. 2A is equal to 2 times 7 is 14. 2 times negative 2 is negative 4. 2 times 0 is 0. 2 times 8 is 16. 3B is equal to 3 times 0 is 0. 3 times 2 is 6. 3 times 4 is 12. 3 times 3 is 9. All right. So now what we have to do is add corresponding parts of A and B. 14 plus 0 is 14. Negative 4 plus 6 is 2. 0 plus 12 is 12. 16 plus 9 is 25. And our final answer is 14, 2, 12, 25. The one thing, kind of remember your PEMDAS, because in PEMDAS you must do multiplication before you do addition or subtraction. Likewise, if you're doing 2A plus 3B, you must multiply 2 times A and 3 times B before you actually add them. All right. So I hope this wasn't too challenging. If you have any questions, let me know. Again, matrices, like I said in the last video, are not too difficult, but sometimes what we're doing gets very computational heavy. All right. So if you have any questions, let me know. Check out the rest of the website and have a good one.